Hello, my name is Noha, and this is Lab 1 Constant Velocity for Physics 2211. The purpose of this lab was to observe the motion of an object at a constant velocity, analyze the video of the moving object using tracker and get its position over time, use GlowScript to construct a model that has the same time interval and velocity, and lastly make a comparison between the observation and the computational model created using tracker and GlowScript. For fundamental principles, we want to know Newton's first law, which is an object at rest will remain rest and an object in motion will remain in motion unless an external force intervenes. In this scenario, the object we're examining moves at a constant velocity under the assumption that external forces can be neglected. For Newton's second law, force equals mass times acceleration, and since our velocity is constant, our acceleration is zero, which means the net force is also zero. For momentum, momentum equals mass times velocity, and in this case, our momentum does not change since the velocity is constant. We also want to use velocity update formula, which is final velocity equals initial velocity plus acceleration times delta t. Position update formula is final position equals initial position plus average velocity times delta t. So let me just go over the result of this lab. The two models initially aligned at the same point diverged over time with the predicted position exceeding the observed position. For this experiment, I used the ball, which moved in the positive x direction. So the system is the ball, surroundings are basically everything else than the ball. The initial position of x was 0.01334 meters. The initial velocity of x was 0.649048 meters per second, and change in x position over change in time was used to calculate it. And the total time was 2.169 seconds. I used GlowScript to create a computational model, and for initial conditions, the mass was 1 kilogram, initial position vector was 0.01334, initial velocity vector was 0.649048, which is basically same as tracker. For the second part, time was 2.169 seconds. The net force was basically zero. Ball velocity was same as the initial velocity since F net is zero. And ball position, I just used position update formula. In this case, velocity, the average velocity was initial velocity plus final velocity divided by 2, so which is also just same as the initial velocity. After creating the models, I created a scatter plot to compare them. So the predicted model was basically a straight line. The observed model also looked like a straight line, but it's slightly curved down over time. So two lines are pretty even in the beginning, but the predicted position line starts to exceed the observed position over time, so there's a discrepancy. Since this experiment is held by a human, there are possible sources of errors. The floor may not have been perfectly flat, and this may have changed the acceleration of the object. The ball did not roll in a straight line, causing errors in accurately measuring velocity and position. When capturing the object's position using the tracker, there may have been minor deviations in accurately identifying its exact location. So what if the axes were flipped? The current model measured changes in x position in the positive direction, which formed a positive slope on the position versus time graph. So interchanging plus x and negative x would result in the graph moving downwards, which is a negative slope. And as you can see in the figure on the right hand side, it'll look like that. However, the properties of constant velocity won't change. And lastly, is it possible to say how many pushes and pulls were added together to give zero net force? A net force of zero means that the object is in a state of equilibrium, which forces effectively cancel out each other. This implies that the acceleration is zero and that the velocity is constant. In this experiment, we can consider friction, air resistance, and gravitational force acting on the object, but it is not possible to precisely determine the amount of pushes and pulls. Alright, that is for today, and thank you for listening.